This video covers section probability D. Now in this video we're going to look at theoretical probability. So in the last section we looked at having theoretical probabilities or experimental probabilities. So here we're going to look at the theoretical ones. Now calculating theoretical probabilities, the probability can be considered as a fraction of successes in the long run. So the probability is going to be number of success over number of trials. Now for situations with equally likely outcomes, the probability can be calculated as P equals the number of ways to succeed over the number of all possible ways. So if we looked at the probability of tossing a 2 on a die, it's going to be the number of ways we can have that. Well, there's one number 2 on a 6-sided die, and the number of all possible options are 6. So it's 1 in 6. There's 1 2 out of 6. Now the probability of an event can be hence determined by dividing the number of outcomes in the event, NE, by the total number of outcomes in the sample space. So we've got probability of E is the number of outcomes in the event divided by the total number of outcomes in the sample space, which we can express like that. Probabilities can be written as fractions in lowest terms or decimals. When reporting probabilities, we often use percentages. So let's look at some examples. Determine the probability for each of the following events. Rolling a score of 2 or less on a die. So what we're looking at is a probability of getting less or equal to 2 on the die. Note this terminology. A lot of people, when they submit assessment to me, forget about using the correct terminology. So I want probability less than or equal to 2. Well, let's think about what we could have. We can have 1. Or we can have 2. So there's 2 possibilities out of 6, which we would simplify to be 1/3. Next, selecting an even number from, and we have a number of possibilities, but only one of those is even. So the probability of even is going to be 1 out of 1, 2, 3, 4, 5. 1 out of 5. Again, note the terminology. Next, you might want to try these yourself. Pause the video, have a go, then press play again. Okay, I'm trusting you to do that, please. Okay, so hopefully you're back again after trying these. Choosing a red ball from a bag containing 3 red balls and 9 blue balls. So we're looking at the probability of red, and there were 3 red out of 9. So that will reduce to 1 in 3. Next, winning a raffle after buying 2 tickets of the 150 tickets sold. So the probability of winning, you've got 2 out of 150 tickets. So that would reduce to 1 over 75. Now, calculating probabilities from compound events. When considering compound events, probabilities can be calculated by first listing the sample space. This can be done with the help of the lattice or tree diagrams, which we covered at the beginning. Now, both the total number of outcomes and the number of outcomes in the event can then be determined from the sample space. And we're still going to use this same kind of formula. Probability is going to be the number of outcomes in the event over the total number of outcomes in the sample space. So let's look at the examples here. If 2 children are born to a family, and we're going to assume that there's equal chance of getting a boy or a girl. So list all the possible outcomes. So I'm going to use a lattice diagram. I'm going to have first child and then second child. Oh, and I can't write. Second child. Okay, so my first child could be a boy or a girl, and my second child could be a girl. Oh, I should do it probably in the same order as well. A boy or a girl. So the combinations here, I can have boy, boy, girl, boy, boy, girl, girl, girl. So these are this is our sample space here. How many outcomes are there altogether? There's 4. We've got boy, boy, girl, boy, boy, girl, girl, girl. Assuming that the probability of having a boy and a girl are equal, find the probability of having 2 girls. Well, the probability of 2 girls is just the probability of getting GG. Now that happens once out of 4. Next, a boy and a girl. So the probability boy and girl. Now we can have the probability of getting a boy then a girl, or probability of getting a girl then a boy. So there's 2 possible ways of having, or 2 possible options there out of 4, which is half. You have a 50% chance. Next, if 3 coins are tossed, list all possible outcomes. Now 3 coins, we want to do this in a very methodical, systematic way. So we're going to use a tree diagram. So head, tail, and then from there I can get head, tail, and from there head, tail, head, tail, head, tail, head, tail. So our possible outcomes are head, head, head. So this is called my sample space. Head, head, tail, head, tail, head, head, tail, 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 head, head. You can just see I'm reading across the tree. Tail, head, tail, 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 head, tail, tail, tail. Now how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8. Find the probability of each of the following. So probability of 3 heads. That only happens once out of 8. It's that one there. Probability of 2 heads. Well, if we look at my tree diagram, that has 2 heads, that has 2 heads, that has 2 heads, and that's it. So we've got 1, 2, 3 out of 8. Now the probability of no heads is the same as getting 3 tails, which is simply 1 out of 8. So what now? Practice probability D1 and probability D2 in the textbook.